Okay, in this video I will show you how to get the inverse of a function. But first, what is an inverse? Okay, let's think about it as adding and subtracting. We also have multiplication and division, or a squared and the square root. For example, you have 2 plus 3 equals 5, or 2 times 3 equals 6, or even 2 to the 3 equals 8. But how can you go back from the 5 to the 2? Well, you have the inverse of plus, which is the subtraction. So if you subtract 3 from 5, you will get the 2. As we know, the multiplication is a conjunction of a lot of sums, but it also has an inverse, which is the division. So 6 divided by 3, you get the 2. Now let's go to the exponent. If you get the third root of 8, you will also get the 2. Having the result, you can go back to the initial number you had. But what about a function? Let's look at this function. 2x plus 1. We know that f of x is the same as y. So y is the same as 2x plus 1. Okay, now let's add the inputs from 1 to 4. We get 3, 5, 7, and 9, which are the coordinates. Now let's graph it. Okay, so here now we have the graph. But how can we go from the 3 back to the 1? This is why we need an inverse of a function. Okay, we have here the same function. But in order to do the inverse of a function, we have to treat it as an equation. So, y equals 2x plus 1. We have to leave the x alone. So, you have to do some algebra. First, we pass the 1 subtracting, and then we pass the 2 dividing. Now we have x alone. The next step is to change the y to the x, and this equals the inverse of the function we had. Now let's see how this works. With the number function, you have as an input 3, and you get as an output 7. But with the inverse of a function, you can use the output as a new input, and you will get the previous input as the output. So this is how we can get the inverse of a function. But what about the graphs? Here is the previous graph we had. Here are the coordinates. This number is the input, and this number is the output. Now let's use the 9 as the input for the inverse of the function. Let's see what we get. We get 4. That means the coordinates are the same, but they are switched. So how does this affect the graph? Let's graph it. Here is the graph of the inverse of the function. Okay, it looks almost the same. Now let's put them both together. As you can see, they are pretty different. Now, how can you mirror a function but only having the graph? Okay, first we will make a 45-degree angle line that we will use as a mirror. These two graphs are perfectly mirrored one to another. As we can see, the space from the function to the mirror is the same as the mirror to the inverse function. So now that you know how to make the inverse of a function, I want you to practice. Now I want you to find the inversion of these three functions. You can pause the video if you like. When you've finished, I want you to find the inverse function that using 8 as an input, you will get minus 1/3 as an output. And I want you to graph that specific inverse function. Now let's talk about the functions that are not invertible. This means the inverse of a function will give you as an output one number when there is actually more than one. There is a fast and easy way to know if the function is not invertible. This way is simply making an horizontal line. If the horizontal line touches more than one point, then it means that if you put as an input in the function one of those points, it will give you the same point in the y-axis. So when you use the inverse function, it will not give you those 2 points. One of the ways this won't happen is putting a restriction. For example, in this graph, the restriction will be x has to be bigger than 1, and this will solve the problem. Of course, this doesn't mean that if you put a bigger number than 1, it will just give you half the graph. What it means in this specific graph is that after you graphed, you will only use half of the graph as your whole graph. And for the last exercise, I want you to tell me why f of x, being the exponent of x bigger than 1, is not invertible, and prove it.